Alright guys, let's look at lesson 7, which is electron configurations. So what are electron configurations? Electron configurations are notations that indicate placement of electrons in a neutral atom. They build off of the orbital diagram that we talked about in the previous unit. The lowest energy sublevel is written first, so that would be the 1s, and then remember we work up our chart. And then the number of electrons in each sublevel is written as a superscript or an exponent. So this is what the electron configuration for carbon would look like. The type of the orbital is written, the energy level, and the number of electrons in that energy level. And it's read as 1s2, 2s2, 2p2. So when you're writing electron configurations, you need to have a number first, which denotes what energy level you're talking about. Then you have a letter denoting the type of orbital, so S, P, or D. And then you have a superscript, which will tell you how many electrons are in that orbital. So let's look at the periodic table. We fill orbitals in increasing order of energy, and the different blocks on the periodic table correspond to the different types of the orbitals. So for example, here is a shot of the periodic table, and it's broken down into where the different orbitals are. And so when you write your electron configuration, it's pretty easy because when we write these, we know what the end of the electron configuration should be for the element based on where it is located on the periodic table. And then you just have to make sure that you fill up all of the other energy levels that are below it first. So let's look at another way that we can do this. That is the electron configuration shorthand, or the noble gas configuration. So when you write the shorthand configuration, you use the noble gas in the period or row above the elements, and you write that in bracket first. Then you finish off the noble gas configuration with whatever electrons are left. So for lithium, helium would be the electron that is, or the noble gas that is above it all the way to the right. And then we would finish it off with 2s1, because that's where lithium is located on our periodic table. The easiest way for you to see this is for you to just do it. So let's write the electron configuration for beryllium. So beryllium, it has 4 electrons. So our electron configuration is going to be 1s2, 2s2. And then we need to write the shorthand electron configuration for beryllium. The shorthand electron configuration, and remember, it includes the noble gas in brackets. So when you look at beryllium, it's in period 2. You go up a row all the way to the right. That's the noble gas that you're going to use, which is helium. And then you just finish off what is not in helium's configuration, which would be the 2s2. Alright, so let's look at the electron configuration for oxygen. Oxygen has 8 electrons in it. So the electron configuration would be 1s2, 2s2, 2p4. And then we're going to write the shorthand electron configuration for it. So again, the noble gas that you're going to use is helium. So then helium takes care of the 1s2. So then just write what's left, which is 2s2, 2p4. Now let's try a practice. What is the electron configuration for aluminum? Pause the video and then unpause when you're ready. Well, you should have figured out that aluminum has 13 electrons, so let's write out the electron configuration for aluminum with 13 electrons. So 1s2, 2s2, 2p6, 3s2, 3p1, and then we're going to write the noble gas configuration. Well, the noble gas that's above aluminum on the periodic table is neon, so we're going to write neon, and then neon's configuration is 1s2, 2s2, 2p6. So then what's left for the shorthand is just 3s2, 3p1. All right, let's look at check your understanding. So write the electronic configuration for calcium, and then write the shorthand electron configuration for calcium. We're going to check that first thing in class tomorrow. Have a good night.